morning, everyone. Welcome to our last lesson in Chapter 11. This is 11.5, and we are applying the distance and midpoint formulas. Now what we're going to start with is the distance formula. So what the distance is the distance between any 2 points, x1, y1, and x2 and y2. That formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So when we would use this is if we would have something on our graph where we would have a point and another point. Now we can't count diagonally, so what we would do is use our distance formula to find the distance between one point and the other. We could also do that same thing if we were looking for the distance of the sides of a triangle. We could use our distance formula to figure out what the distance between any two of those points are. So let's try this. Find the distance between 2 points. Well, I got two points here. I have an x, a y, an x, and a y. The first x I have is going to be x1. Second x would be x2. First y is y1. Second y is y2. So what we got to do is find the distance between these 2 points. So I'm going to find the square root of, the first one is x2 minus x1, so negative 4 minus 6 squared plus y2 minus y1, so y2 is 7 minus negative 2 squared. So then we have to solve this. So negative 4 minus 6, well, that gives me a negative 10 squared plus 7 minus a negative 2 makes it 7 plus 2. So 7 plus 2 is 9 squared. The square, negative 10 squared is going to be 100. 9 squared, that's going to be 81. So we have to find the square root of 181. If we do that, then our distance, or our d, is going to equal, I'm going to put this into my calculator, about 13.45. Next one, let's start by labeling what we have. We have an x1, an x2, a y1, and a y2. So we're going to start our distance formulas with our x's. So x2 becomes 2. x1 is minus a negative 2. Plus, don't forget the squared, plus 5 minus 1 squared. So the square root of 2 minus a negative 2, that becomes 2 plus 2, so it's 4 squared. Plus 5 minus 1 squared is also 4 squared. So 16 plus 16, we get the square root of 32. Our distance then, if I put that into the calculator, I know it's not a perfect square. That's why I need to put it in. We get about 5.66. Alright, next problem says use the distance formula and the converse of the Pythagorean theorem to determine whether the points are vertices of a right triangle. Well, first thing we need to do is start off with our distance. First thing I'm going to find is the distance between negative 5, negative 2, and 0, negative 4. So I'll find the distance there then My x2 is going to be 0 minus my x1, which is a negative 5 squared, plus y2 is negative 4 minus a negative 2 squared. 0 minus a negative 5 becomes 5 squared, plus negative 4 minus a negative 2 becomes negative 2 squared. So 5 squared is 25, plus 4 comes the square root of 29. So I'm just going to leave it as the square root of 29 for now. I'm going to find my next two distances, 0, negative 4, and negative 2, 3. So this is going to change our x's now, and our y's. Our x2 this time is negative 2 minus 0 squared plus 3 minus a negative 4 squared. So we get negative 2 squared plus 3 minus a negative 4, that adds together, and we get 7 squared. So negative 2 squared is 4 plus 49. 4 plus 49 gives me 53. I'll leave that for now as well. Then we have to find our last two, the distance between negative 5, negative 2, and negative 2, 3. So this one is here and here. So our x2 looks like it's going to be negative 2 minus a negative 5 squared plus 3 minus a negative 2 squared. Negative 2 minus a negative 5 becomes 3 squared, plus 3 minus a negative 2, that becomes 5 squared. So we get the square root of 9 plus 25. Square root of 9 plus 25, that gives me 34. So now my 3 points are the square root of 29, the square root of 53, and the square root of 34. Now it looks like my highest number is 53, so I'm going to make that my c. So the square root of 53 is my c. Now I'm going to just add these together to see if they are a right triangle. So we have the square root of 29 squared plus the square root of 34 squared. All of these are going to cancel out. So we get 29 plus 34 equals 53. 29 plus 34 is going to give me 63. 63 does not equal 53, so this is not a right triangle. Alright, now the midpoint of a line segment is the point on the segment that is equidistant from the endpoints. So it means it's the same distance from either A and B. You can find the coordinates of the midpoint of a line segment using the following formula called the midpoint formula. The midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Basically what we're doing is finding the average. So if we apply this then, our x1 is going to be 11 here, our x2 is going to be negative 9, y1 be negative 4, y2 is negative 4 as well. So we'll have x1 plus x2, 11 plus a negative 9 divided by 2, and negative 4 plus a negative 4 divided by 2. 11 plus negative 9 is 2 divided by 2. Negative 4 plus negative 4, that gives me a negative 8 divided by 2. So then my point turns out to be 2 divided by 2, which is 1, negative 8 divided by 2, which is negative 4. So my midpoint is 1, negative 4. Over here, our x2, or x1 and x2 are 2 plus 5 divided by 2. And our y1 and y2 are 7 plus 3 divided by 2. 2 plus 5 is 7 divided by 2. 7 plus 3 is 10 divided by 2. 7 divided by 2 is 3.5. 10 divided by 2 is 5.